Okay, I wanted to do a quick video here to help you out with number 5 on your homework worksheet 1J. This is very similar to what you saw in number 4 on worksheet 1I, although that one had overlapping triangles. So this one does not have the overlapping triangles, but the concept here that we're trying to get is we're trying to use congruent triangles to verify or show that something else is true. So basically we're making a little proof here. I'm okay with some different ways of setting it up. So I'm going to do a little bit different on here than I have on my answer key. Just for the sake of time, I'm not going to write out that one. I kind of wrote out sentences. The key is what are we saying is true and how are we getting to that conjecture. So we're trying to prove this conjecture is an idea. Remember, conjecture is a hypothesis, educated guess. It's like in science class when you make hypotheses. And something that we're going to verify. How do we know this is true? The given information are like facts that we know. Okay, so that could be marked in the picture for you. In this case, it's given to us over here with some statements. So we're allowed to use that, and anything else we absolutely know is true. We have to be careful with the absolutely knows are true, but we have talked about a couple of those. So vertical angles, those angles that are opposite from each other might be something, or shared sides are things that we're going to look for. Okay. So just a quick reminder on reading angles. Angle KJL. Angle KJ. K to J to L. When I read that, I literally make that angle. That's the angle that we're talking about right here. Is congruent to angle KJM. Is on the other side. So we have a pair of congruent angles there. Mark that in my picture, and then JL is congruent to JM. JL is congruent to JM. That's those two segments. Okay, so I've got two triangles here. The first thing I know is that angle KJL is congruent to angle KJM. That's given to us, and then JL. So I realize I'm just rewriting the things that they told us. So there might be a little bit more of a reason to do this if they told us maybe that we had a bisector. If JK bisects angle MJL, then we would be saying those angles are congruent because we have a bisector. So we're just kind of taking some baby steps here. Now, the other thing that I want to recognize is that we have this shared side in the middle, and that we know gives us a congruence. So I'm going to add to this that we know that JK is congruent to JK. That's a shared side in those two triangles. Okay, so now we have gotten to the point that we know that the two triangles have to be congruent to each other because that's meeting our side angle side criterion. So these three dots that I'm putting read as therefore. It's just kind of a shortcut. You can also just put a word, or you can just list the next step that we're ready to say that triangle, excuse me, triangle JKM. Now remember to name my other triangle in reverse, so I don't just want to say LKJ. I want to start with the corresponding vertex since these are a reflection of each other. I'm going to start with J again, JKL. Now, here's the part that we want to do about justifying the conjecture. We've talked quite a bit about this, but we just need to get this in our heads that the power of the statement I just made, the one where I said triangles are congruent, the power of this is in reference to triangles. By definition, congruent polygons, and therefore congruent triangles, have all corresponding parts and sides congruent. So, I've only said 3 so far. That was enough to verify the triangles are congruent. We agreed upon that. Now I could go and mark everything in those two triangles. So I could mark these congruent, I could mark those congruent, and I could mark these over here. Now, the ones that I specifically want to do in order to get me to JK as a bisector, remember bisects cuts in half, creates two equal parts. I want to bisect angle MKL, which means I want to say that those two angles, the last ones that I mark congruent are congruent. I'm not going to list the rest of them. I could, okay? But if I'm trying to create kind of a concise argument here, I'm going to say angle MKJ is congruent to angle LKJ. Pause, follow my labeling. MKJ labels this angle. LKJ is me naming this angle. And that's really me referencing my definition of congruent triangles. Okay, we might have used this shortcut in your class, CPCTC. Remember, that stands for corresponding parts of congruent triangles are congruent. That is my definition of congruent triangles. So I like to just say definition of congruent triangles because that's what I'm thinking through in my head. And it might feel like we're done there, but the question was, is the conjecture JK bisects angle MKL true? So that's really the result of the fact that those angles are congruent. And again, we've talked more about bisecting a segment. Bisecting an angle means we're cutting that angle in half. So I'm just concluding with, that means JK bisects angle MKL by definition of bisects. And that is a really solid argument that we're going to call a proof. Okay, so again, if you want to check out my answer key, I wrote like sentences at the beginning, but I wanted to make it real clear that I was doing these 3 congruent statements. So sometimes I just like listing them. That's a nice format too, to get those 3 congruent statements that then lead to this powerful triangle congruent by one of my criterion, which is three things. Okay, so big idea from this unit is we need to be understanding how congruent triangles work, how I can use those. See if you can make sense of the other couple that I gave you to try. Okay.